Hello and welcome to our NNDL project final presentation. This is team number 126. I am Rityunjay Joshi. My teammates are Divit Kalathil and Omkeshwar Shukla, and our topic is sentiment analysis on neural networks. Coming about talking about the problem statement that we have chosen, we have decided to work on natural classification and sentiment classification, to be specific, of natural language data, and particularly we have tried to focus on data from gaming and tech entities. So in our everyday life we have a lot of data on games, while someone is gaming or someone is live streaming, they often engage in commentary on social media. They also review games, they also review technology products. So that is the kind of data that we have focused on for this project, and we aim to develop some robust deep learning models to classify this data into various the sentiments. We have taken this data from Kaggle, and in code we leverage Kaggle API to directly fetch this data from Kaggle website instead of downloading it from the source. Coming to data exploration, we utilized in the towards data cleaning, we did some data cleaning, we removed duplicates, we also handled missing values, and we applied some text pre-processing techniques like cleaning, tokenization, etc. And we also generated some visualizations, one of which is visible over here on the left in this slide. This is essentially a word cloud, and it is among the fancier visualizations that we generated, hence it is in this deck. We can see that the most commonly occurring words over here are game, PS5, YouTube, Xbox, etc. So this is these visualizations gave us a better understanding of the data set, etc. So coming to our baseline model has been LSTM. LSTM is essentially a specialized recurring neural network. Why we chose LSTM? Because to handle sequential data, recurring neural networks are the use case, and recurring networks are the go-to thing, and to are the go-to thing, and to the natural text that is generated is essentially sequential data, hence we leverage LSTM to train a model for the sentiment classification use case. Talking about the implementation of LSTM, we had an LSTM layer with a dropout followed by dense layers for feature extraction, and for training we utilized metrics like accuracy and cross entropy loss to evaluate the model. Coming to the model training and evaluation, we split the dataset into training and test sets, and we also did some hyperparameter tuning uh, using k-fold cross validation, and we got accuracy of 93% for LSTM and a loss of 0.0463, along with the confusion matrix that can be seen over here. Coming to the model performance, over here we can see that LSTM performed the best among the three, which is a reason for that can be attributed to the fact that LSTM handles has an in-memory processing loop, which makes it more aware of the previous state while dealing with the current state, whereas even though RNN has feedback loop, but it has an inferior, or LSTM is a more state-of-the-art architecture, hence we got more accuracy for LSTM. And we also saw a non-deep learning based, or a single activation function machine learning algorithm like logistic regression, which gave us an accuracy of 87.41%, as it can be seen over here. So coming to the accuracy, as I already discussed, I pretty much covered what's in this slide. Essentially, we got the accuracies as I showed. Those are 93%, 91%, and 87% respectively for LSTM, RNN, and logistic regression. Over here, the RNN that we used is like a vanilla RNN, and LSTM is like the specialized RNN that we used. And both RNN and LSTM give like a higher precision and recall value uh, compared to the logistic regression. Coming to the conclusion, we see that LSTM emerges as the top performer, and showcasing that like its superiority in dealing with textual data. Some future work that we have already worked on fine tuning the hyperparameters, and like we have already used k-fold cross validation technique to do that, and we can enhance the pre-processing techniques, like we can use word to vec to vectorize the word instead of like using one hot encoding, and we can do some more domain specific tuning of the data and the model, which can be a better niche, which can fit this niche.